Hello. In this session, we will discuss about methods of expressing concentrations like molarity, normality, molality, mole fraction. What is the meaning of this? What is the amount of solute present in given amount of solvent or given amount of the solution? It is known as methods of expressing concentrations. We use some terms here like standard solution. Standard solution means the line is very simple concentration known solution. In your questions it will be given like this: 0.1 molar HCl is supplied. When this kind of terms are there, 0.1 means the concentration, but the concentration is known here. When the concentration is known, the solution is called a standard solution. So if you want to express the concentration, you can say it on the basis of solubility, weight fraction, volume fraction, weight fraction with respect to volume, volume strength, you can say volume strength is special case, parts per million, molarity, normality, molality, mole fraction, formality. All these we'll discuss one by one. First, weight fraction, or you say weight percent. Percentage weight by weight. Very simple. Percentage weight by weight is equal to number of grams of solute dissolved in 100 grams of solution is called weight percent. So weight of solute, write all this formula in your notes, by weight of solution, both must be in grams better, into 100. Percentage weight by weight whenever you want to calculate, weight of solute in grams by weight of solution in grams into 100. Volume percent, percentage volume. Number of milliliters of solute dissolved in 100 ml of the solution. Both are volumes better. Number of milliliters of solute dissolved in 100 ml of the solution. Otherwise, if you want percentage volume by volume formula, volume of solute, it must be in milliliters, divided by volume of solution. This must also be in milliliters, into 100. Percentage into 100, that's all. Volume of solute by volume of solution into 100. Both must be in milliliters. Next, weight volume percentage. Percentage weight by volume. So here you are going to say the weight of solute and volume of solution. So weight by volume percentage is equal to weight in gram of solute, volume of solution. Generally volume of solution will take in milliliters, into 100 percentage. Weight in gram by volume of solution into 100. This is weight volume percentage. Weight by volume percentage. Along with this, we have another one. We generally show ppm, parts per million, like that we show. Number of parts of solute present in million parts of solvent. Number of parts of solute present in 10 power 6 parts of solvent. More than this, the molarity normality terms are important. About parts per million we'll discuss in hardness of water. I will give you one special video related to that. And hydrogen peroxide concentration, that is also very special. That is also we'll discuss in a particular term. Now molarity. I am giving you only formula here, definition and formula. For each formula, if you want, I will give you individual worked exercise session. Okay. Molarity means number of moles of solute present in 1 liter of solution. Number of moles of solute in 1 liter solution. So 1 liter means we are discussing about volume beta. As this is volume based, it is temperature based also. It is going to depend on temperature. Molarity depends on temperature. This point you remember. And units also important. Moles per liter. Number of moles of solute in 1 liter of solution. So moles per liter beta. Next is molarity formula. Molarity is equal to N by V, where N is number of moles. Molarity is equals to N into 1000 by V if volume is given in milliliters. Molarity is equals to weight by gram molecular weight into 1 by V if it is in liters. Weight must be in gram beta. Molarity is equal to weight by gram molecular weight into 1000 by V if V is given milliliters. All these are molarity formulae. Only one formula, we are just expanding it. Number of moles by volume. Sometimes what they will ask you is, what is the weight of the compound? What is the weight of the solute? In such kind of cases, weight is equal to molarity into gram molecular weight into volume. If volume is given liters, otherwise volume by 1000 if volume is given milliliters. This is to calculate the weight of the solute. One other important formula. The important lines are molarity is equals to percentage weight by volume. If percentage weight by volume is given into 10 by gram molecular weight, molarity is equals to percentage weight by weight. When weight by weight is given, they will give you density also better into 10 by gram molecular weight. Percentage weight by weight, percentage weight by volume. Okay. When weight by weight percentage is given, density will be given. That also you need to multiply. Then dilution law. The dilution law is M1V1 is equals to M2V2. Dilution law means, for example, 100 ml of solution is there with some concentration. So that you are adding 200 ml extra water, 300 ml extra water, 400 ml water, 1 liter water. In such kind of cases, it's called dilution. The concentration changes. M1V1 is equals to M2V2. Fine. One other law is, what is the volume of water to be added? Volume of water to be added in dilution beta. In dilution, volume of water to be added is final volume minus initial volume. V2 minus V1 is the amount of water to be added for dilution. Done. Next formula, molarity. They can ask you for a solution by mixing two acids or two bases. So I am saying final molarity is equal to M1V1 plus M2V2 by V1 plus V2. Okay, this is for two acids or two bases mixed. If two acids or two bases are mixed, the formula is M1V1 plus M2V2 by V1 plus V2. Final molarity is equal to two acids or two bases. If in this case, you just see what I am doing. M1V1 minus M2V2 acid plus base. If one acid and one base is added, then the formula is m1 v1 minus m2 v2 by v1 plus v2. It is same beta, total volume is same. Final molarity is equal to m1 v1 minus m2 v2 when you are adding one acid, one base. If both are acids or both are bases, this must be plus term. One is acid, another is base, that should be minus term. Then neutralization law. Neutralization means exact amount of acid or base to another exact amount of acid or base. For this purpose, we use m1 v1 by n1 is equals to m2 v2 by n2, where n1 and n2 are number of moles present in the stoichiometric equation, number of moles of acid, number of moles of base. For example, if you are taking HCl plus Na2CO3, in order to balance this equation, we need 2 moles of HCl beta, CO2 plus water. This is 2 moles. So n1 is equals to 2, n2 is equals to 1. Number of moles of acid n2, number of moles of base 1. So n1 and n2 values are taken from that. Neutralization law, this is. Neutralization, dilution, percentage is weight by weight, percentage weight by volume. Then 2 acids mixed, 2 bases mixed. These are the important formulae for the molarity. Same thing now we will discuss for normality. Given by n, number of gram equivalents of solute in 1 liter of solution. Again 1 liter, volume based. When volume based means temperature dependent. Normality also temperature dependent. Units, the previous one we were saying moles per liter. For molarity, here gram equivalents per liter. Normality, number of gram equivalents of solute. What is gram equivalent? What is number of moles and what is gram equivalent? What is the difference? It's very simple. Number of moles is equals to weight by gram molecular weight. Number of gram equivalents is equals to weight by gram equivalent weight. You know how to calculate the equivalent weight? We'll discuss that equivalent weight one special class, but I will give you equivalent weights one another class. You just apply here the same things. So the formula for normality. Normality is equals to weight by gram equivalent weight into 1 by V if it is in liters. Normality is equals to weight by gram equivalent weight into 1000 by V if it is in milliliters. Normality is equals to number of gram equivalents volume in liters, or normality is equals to number of gram equivalents into 1000 by V if it is in milliliters. Remember some other terms also, millimoles and milliequivalents. 1 mole is equals to 1000 millimoles. 1 equivalent is equals to 1000 milliequivalents. Okay, these are the basic formulae for normality. The special formulas are, right, copy somewhere. Normality is equals to percentage weight by weight into density into 10 by equivalent weight. Same formula like molarity, just this term is different. Percentage weight by volume when it is given, no density. And the important formula is neutralization and dilution. For neutralization and dilution, there is only same formula, that is one formula only. N1 V1 is equals to N2 V2. In the previous case, there were two different laws. M1 V1 is equals to M2 V2. M1 V1 by N1 is equals to M2 V2 by N2. But here, N1V1 is equals to N2V2. Both are same. So normality, percentage weight by weight, percentage weight by volume, neutralization, dilution, volume of water to be added, same formula. Volume of water to be added is V2 minus V1. Done. Then two acids, two bases formula will be same. When two acids are mixed or two bases are mixed, final normality is equal to, as we were discussing just now, N1V1 plus N2V2 by V1 plus V2. Two acids and two bases. Similar, M1V1 plus M2V2 by V1 plus V2 in molarity. Here also same thing. But now, instead of two acids and two bases, if one acid and one base is mixed, one acid and one base is mixed with, then final normality is equals to, this is minus term, N1V1 minus N2V2 by V1 plus V2. Okay, very similar formula. Then the most important one, normality is equals to molarity into n factor. What is n factor? Normality is equals to molarity into basicity for acids. This is only n factor. Normality is equals to molarity into acidity, which is for bases. Normality is equals to molarity into n factor beta. You can take here charge of, complete charge of either cation or anion. Otherwise, the number of electrons involved in oxidation case and reducing case. This kind of things. Number of electrons involved. We'll discuss particularly one session to calculate these things. I will give you just 2-3 simple examples. You see, H3PO4, H3PO3, H3PO2. Okay, now the basicity of this is H3PO4 is tribasic. Basicity, this is 2 and this is 1. Don't decide based on hydrogens, but decide based on the structures. H3PO4, H3PO3 and H3PO2. Basicity. Fine. Now, here, if you want to calculate the molarity, for example, let us say the molarity is 0.1 in each case. Then the normality will be 0.3 here, 0.2 here and 0.1 here. Because this we are multiplying by 3, by 2 and by 1. Okay. We will discuss one particular session for calculation of normality. I will be updating that very soon. Normality, just numericals of normality, basic numericals of normality to advanced one. But here you remember this one, this is important one. Normality, H3PO4, H3PO3 and H3PO2. Then after normality, we have one other important one, that is molality. Molality is given by small m, number of moles of solute. Up to here it looks like molarity present in 1 kg solvent. The differences you see, here 1 kg, there it is 1 liter in molarity. Here it is solvent, there that is solution. Okay, so these are the differences. Number of moles point is same. But here mass is there, so there is no dependence of temperature, it is temperature independent. These lines are important. Temperature independent it is. Units will be number of moles, so mole per kg. Units are moles per kg, number of moles of solute present in 1 kg of solvent. So the formula molality is equals to N by weight of solvent in kg, or molality is equals to N into 1000 by weight of solvent in gram. Okay, in place of N you can write weight by molecular weight. That's fine. These formulae are important. Molality is equals to solubility into 10 by gram molecular weight. And the most important formula is the relation between molarity and molality. Molality is equals to 1000 m by 1000 d minus m into gram molecular weight. Okay, here gram molecular weight. Okay, gram molecular weight we need to take. M is molality. Molality is equal to 1000 m. This is molarity beta. Capital M is molarity. This is molarity beta. 1000 d. Okay. Why we are taking this? 1000 d means actually we are getting the complete weight of the solution, and we need to subtract the weight of the solute. So weight of the solution minus weight of solute, you are getting there weight of solvent. So this must be of solute. Molality is equals to 1000 m by 1000 d minus m into gram molecular weight. That the meaning of this term is we need to subtract the weight of the solute. Don't confuse weight of the solute. So this is one important relation that you need to remember. Then mole fraction. This is given by chi. Okay, now it looks like x. Actually it is chi beta. You can say x also, no problem. Actually it is chi. It is a ratio between number of moles of one particular component to the total number of moles of all the components in solution. Okay, it is a ratio between number of moles of one component to the total number of moles of all the components. So it's ratio, so no units are there. x1, okay, now chi1 actually you need to say n1 by n1 plus n2. If two components are there, each component number of moles are n1 and n2. So x1 will be like this, and x2 is n2 by n1 plus n2. Mole fraction chi, it has no units because it is just a ratio. Chi1 is equal to n1 by n1 plus n2. Chi2 is equal to n2 by n1 plus n2. Interesting thing is chi1 plus chi2 is equal to 1. The sum of mole fractions must be equal to 1 beta. Sum of mole fractions is equal to 1. Formality is another one. It is given generally for ionic compounds. Formality is same like molarity. Formality and molarity both are same, but only thing is it is given for ionic compound, because ionic compounds you should not say molecular mass. There we say the term formula mass better. That's why formula mass is nothing but molecular mass. In simple, for example, sodium chloride is there. Sodium chloride actually won't exist like sodium chloride molecule beta. Sodium ions and chloride ions attractions will be there. So whatever 58.5 you are saying, that is formula mass, not exactly molecular mass. So the better term you can use is formality. Formality means everything is same. Okay. Here for SO3 and H2SO4 case, one special type of concentration is there. For hydrogen peroxide, for a special type of concentration is there. This we'll discuss in individual videos. Okay, so I was just giving you the formula. If you remember all this formula, you can answer maximum questions. I am not giving you numericals. Numericals for each section, molarity, normality, mole fraction, we'll discuss in another video. Okay, good day. Signing off, Lakshma.